Yeah. Welcome to the summary session of, of session 4. So in session 4, we have discussed the mobile services first. We have discussed mobile services under the heading bearer services, tele services and supplementary services. Two types of bearer services we have discussed, transparent and non-transparent bearer services. We have discussed many teleservices like the main GSM teleservices, telephony, the voice-oriented communication. And then under teleservices, we have also discussed the emergency number, which is provided by GSM for emergency communication throughout Europe. And we have discussed about SMS, short message services, EMS, enhanced message services, MMS, multimedia message services, and Group 3 fax. And under supplementary services, we have discussed user identification, call redirection, call forwarding, closed user groups, these things. Then we have discussed the GSM system architecture. So we have discussed GSM system architecture under various headings like radio subsystems, networking and switching subsystems, and operational subsystem. And then we discussed various components in each of the subsystem like BTS, BSC, MSC, MS, radio cell, HLR, VLR, various register like various registers like equipment identity register, authentication center, operation and maintenance center. So all these things we have discussed under system architecture. Then we have discussed the radio interface, which is an important interface. It is represented with UM interface. Here we have discussed like how the normal burst of the GSM um, uh, data looks like. Okay, so actually the normal burst duration is 577 microsecond, but out of that, mm, 546.5 microseconds were used for actual communication. The remaining will be for God spaces. And in this also the actual data will be transmitted in 114 bits. There will be two user data, each of 57 bits. And then we have discussed the different types of frames. The normal frame, the standard frame or the normal frame, which has 8 slots, okay, with a duration of 4.615 milliseconds, and each slot has a duration of 577 microseconds, and a collection of this so collection of so 8 slots form a frame, okay, and collection of 26 frames form a multi-frame. Collection of 26 frames form a multi-frame, and collection of 51 frames form a control multi-frame. Okay, so and the collection of 51 26 multi-frames will form a super frame, and also the collection of 26 51 multi-frame also will form a super frame, and a collection of 2048 super frames will form hyperframes. So depending on the requirement, different types of frames were used for communication. And then we have discussed the protocol architecture of GSM. Here we have discussed that the protocol architecture of GSM, it mainly takes care of synchronization of path delay and error correction techniques like FEC, forward error correction technique. It also performs voice activity detection, creating comfort noise, all these things, and the various layers of the protocol architecture we have discussed. And then we have discussed localization and calling. So that is, so this part deals with identifying the location of a mobile user irrespective of whether he is moving or staying in the same place. So under this we have discussed, we have defined roaming. We have defined roaming as changing VLOs with uninterrupted availability of all services. And we have discussed different types of numbers like MS ISDN, Mobile Standard International ISDN number, IMSI International Mobile Subscriber Identity, TMSI Temporary Mobile Subscriber Identity, MSRN Mobile Station Roaming Identity. Then we have discussed two types of call setup. Mobile terminating call, where the end device will be the mobile. That is, the call will be received by a mobile. So how mobile terminating call works, we have discussed, and also we have discussed how mobile originated call works, where a call is getting originated from a mobile station. And also we have discussed the message flow for MTC and MOC. MTC is mobile terminated call and MOC is a mobile originated call. In both the cases, how the message flows between the mobile station and the BTS, that we have discussed. And then we have discussed about handover. So handover happens when a mobile station moves from one particular uh, base station to some other particular base station. So what are the reasons for which handover happens? So handover happens for two reasons. One is when the signal becomes very low or the quality of the radio link becomes very low. In that case, handover happens. Sometimes handover also happen for load balancing. And then we have discussed different types of handover, like intra-cell handover, inter-cell and intra-BSC handover, inter-BSC and intra-MSC handover. Okay, all these different types of handover we have discussed. And then we have discussed a timing diagram also for intra-MSC handover. Okay. After that, we have discussed about the security services that are offered by GSM, like authentication, control and access control and authentication, confidentiality, anonymity. We have discussed different types of algorithms, A3, A5 and A8, where A3 is an authentication algorithm, A5 is an encryption algorithm, and A8 is an cipher key generation algorithm. How authentication works, how the random key is used as a challenge response method for authentication, and how encryption was done by using by creating a cipher key. These things we have discussed under security services offered by GSM. And then we have discussed in detail about GPRS, General Packet Radio Services. Okay. So that's it about session 4. So let us stop here. Thank you.